Welcome back. Let's talk about amides. All right, so the big difference now is that our carbonyl carbon is connected directly to a nitrogen, right? And that's what qualifies this particular group as an amide. How you name amides is simply the same way as you name an alkane, except that at the end you drop the last letter, you drop E, and in its place you simply add the word amide. So This type of molecules are not too bad to name. Now, there will be situations where substituents are actually present on the nitrogen atom. So you will have to specify where those substituents are by using the letter N followed by the hyphen. So instead of a number and hyphen, now you have N hyphen to tell that the substituents are explicitly bound to nitrogen and not to the carbon chain. So as an example, you could have a molecule that looks like this. Notice that on the nitrogen, we happen to have a methyl group attached to it, right? The longest chain, though, starting from the carbonyl carbon, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons long. And roughly at 2, 3, 4, 5, positions 5, 6, and 8, we have 3 methyl groups sticking out, right? So as far as the label, what we should say is that, okay, we have a total of 1, 2, 3 methyls, but then there's a fourth methyl on nitrogen. And so notice right here that as far as labeling where those methyls are, I have to also use the letter N. So N, 5, 6, 8, tetramethyl decane, starting off as the alkane, right? And then we simply drop that E and replace it with the word amide. So in total, this is N568 tetramethyl decanamide. All right, here's another example, a little bit more esoteric, perhaps. The If you look at it, there's a couple of things that should stand out. First things first, we have the amide functionality, but we also have a ketone, and on top of that, we have a carboxylic acid. And so here's where you really have to pay attention to the priority of functional groups. And among those three, even though right now we're talking about amides and how to name amides, amides are not the highest priority. In fact, they are one of the lowest priorities among the 6 different carbonyl groups that we've talked about so far. The highest priority is the carboxylic acid. So this tells us that, yes, the longest chain is going to be this whole highlighted section, but position 1 specifically is not going to be at the amide because that's a lower priority group, but rather at the carboxylic acid, right? So position 1 is right here, and then we work our way all the way down to position 9, which happens to be where the amide is located. So as far as naming this thing, we acknowledge that we have an isobutyl group, we have a chloro, a fluoro, a methyl. So we name each one of those things, right? 5 chloro, 7 fluoro, 6 isobutyl, 2 methyl based on the locations where they are present. And then 9 carbons will be nonane. Now, here we have to now acknowledge 3 different functional groups, right? So after nonane, you'll say, okay, so we have the amide at position 9, right? So 9 amides. At position 3, we have one, so 3 one. And at position 1, we have the carboxylic acid, so oic acid. And for the most part, this is in alphabetical order. Now, you'll notice that the ketone and the carboxylic acid are not in alphabetical order. And the only reason for that is simply because the carboxylic acid being the highest priority, usually people try to put that group at the very, very end to emphasize that that is the main functional group. You know, you can make the argument that oic acid ought to go before the ketone, and to some degree you'll be right. But from what I've seen in the past, that tends to mess up the flow of the name. If you went 9 amide, 1 oic acid, 3 one, yeah, the name kind of gets a little bit messy, especially because of the fact that you have that space between oic and acid, right? So that's one tiny little nuisance. But aside from that, the rest of the name is the traditional thing. Everything in alphabetical order. Substituents at the front, and then your actual functional groups at the end. All right. Now, in the case where the amide is sticking out of a ring, You will name the ring as you normally do, but what you will do is you will add a suffix to it, and the suffix is a little bit funky. It's carboxamide specifically. So when you look at something like this, right, we have a four-member ring, and right of the four-member ring is where the amide functionality is located. Now, on top of that, in this particular example, we have two isopropyl groups bound to the nitrogen itself. So what we'll do is say, okay, the two isopropyls are located on nitrogen, so this is N, N diisopropyl. The parent chain is a cyclobutane chain. And then we just have to acknowledge that this is an amide by saying at the end of the name carboxamide, right? So N, N diisopropyl, cyclobutane, carboxamide. All right. And then if the ring, on the other hand, was benzene, right? So aromatic, then you just name it as benzanamide, which is the common name for the aromatic, controversion, right? So here you will say, all right, so you got ethyls, two ethyls. Position one in this case will be where the amide is located. So you'll have the first methyl at position 3 and the second one at position 4. So this is 3,4 diethyl benzanamide. Okay, so that is basically it for amides. And nitriles, the nomenclature, as you'll see, is actually relatively straightforward. You name the molecule as an alkane, you drop the E, and you replace that with the word nitrile, or nitrile, or nitrile. So if you look at a molecule like this, now granted, you're really only going to do this if the nitrile is the only quote unquote functional group present in the molecule. Because if not, then you're probably going to treat the nitrile as a substituent. We'll get to that a little bit later. So now looking at this thing, the longest chain is starting from the carbon of the triple bond, right? The CN triple bond. We have 1, 2, 3, 4, 5, 6 carbons in a row. And then we have 3 methyls attached to positions 3 and 4. So we have 3,34 trimethyl hexanonitrile, right? So this would have been hexane, drop the E, replace it with O-nitrile, so hexanonitrile. All right, now here we have 2 nitrile moieties within the same molecule. The longest chain that contains those will be a 5 carbon chain, right? So 1, 2, 3, 4, 5. We'll have 2 methyls and an ethyl in there. So this is 3 ethyl, 2,4 dimethyl. And then this will be pentane, but then you drop that so that it's now pentano. And because you have 2 nitriles, now you have to specify their positions, positions 1 and 5, pentano 1,5 dinitrile. Okay. All right, and then here's the last point that I was trying to make earlier, which is that when you have other functional groups or higher priority, usually you do not bother treating the nitrile group as a functional group as far as the name is concerned. Instead, you treat it as a substituent. And as a substituent, the nitrile group has a very specific name. We simply call it cyano. So as far as naming this thing, we recognize this is a benzoic acid derivative in which we have a methyl, an isopropyl, and now a cyano group attached to it. So alphabetically, right, we have cyano, then isopropyl, then methyl, and then the numbers are based on the fact that the highest priority for the lowest number is the carboxylic acid. So that's position 1. And then after that, you move so that the values for your substituents are as low as possible, right? So we're moving clockwise in this case. All right, so that basically concludes all the nomenclature. And granted, there is a lot, right? Because we have 6 functional groups in total that we're talking about and looking at for the first time. So be sure to practice, naming some of these molecules and practicing how to go from the name to the structure. But as you'll see in the next set of videos, the bulk of this chapter is the actual reactivity. So although we spend quite a bit of time on the nomenclature, don't make that your priority. Like study it, be good at it, but don't spend all your time on it. Okay, so with all that being said, I'll meet you in the next video. Bye-bye.